What's it actually like to live in space? Not the glamorous version from movies, but the real one. Because the moment you leave Earth, three quiet enemies start working against you: radiation, weak bones, and the pressure of living inside a tiny sealed box where every breath, every meal, and every mistake matters. And the strange part is this: space isn't trying to kill astronauts in one dramatic moment. It's trying to slowly change the body and mind day by day. Let's start with radiation, because this is one of the biggest hidden risks. On Earth, we are protected by the atmosphere and the magnetic field. In orbit, that shield is much weaker. That means astronauts are exposed to far more high-energy particles from the sun and deep space. Why is that dangerous? Because these particles can damage cells and DNA. Over time, that raises the risk of cancer, eye damage, and nervous system issues. It can also cause short-term problems during solar storms, when radiation levels spike dramatically. So how do astronauts deal with it? They use shielding, careful mission timing, and monitoring. Spacecraft are designed with protected zones, and crews may move to safer areas during intense solar events. A practical example: if a mission to Mars is planned, engineers don't just ask, "Can we get there?" They ask, "How much radiation will the crew absorb on the way while staying there and on the way back?" That changes everything. From spacecraft design to mission length. Then there's bone loss. This one sounds subtle, but it is a huge problem. On Earth, your bones are constantly under load from gravity. That stress tells your body to keep rebuilding them. In microgravity, that signal disappears. Without that daily load, the body starts breaking down bone faster than it rebuilds it. Astronauts can lose bone density, especially in the hips and legs, which makes fractures more likely after long missions. The mechanism is basically this: no gravity, less mechanical stress, less reason for the body to maintain strong bones. So what is the fix? Exercise, a lot of it. Astronauts spend hours each day on resistance machines, treadmills, and bikes specially designed for zero gravity. They are not exercising for fitness alone, they are trying to convince the body to keep its skeleton. Concrete example: if someone stays in space for months without proper countermeasures, it can take a long time to recover once they return to Earth. That is why exercise equipment is considered just as important as food or oxygen. Now for the one people underestimate: living in an enclosed environment. Spacecraft and space stations are extremely small, recycled, and fragile compared to anything on Earth. There is no open window for fresh air. Air, water, and waste all have to be carefully controlled and reused. Even a tiny issue can become serious fast. That changes the psychology too. People are not just sharing a room, they are sharing the same air, the same noise, the same limited privacy, and the same high-stress environment for months at a time. That is why space habitats need systems for filtration, humidity control, temperature regulation, noise management, and even conflict prevention. Useful takeaway: this is why space technology often feeds back into Earth life. Water recycling systems, compact air filtration, and remote medical monitoring all get improved because of space research. So living in space is not just about surviving the void, it is about outsmarting biology. Radiation tries to damage the body. Microgravity tries to weaken it. Enclosed habitats test the mind and the systems keeping everyone alive. And the most amazing part: every solution built for space is really a lesson in how delicate and how adaptable human life is. Space Living Explained. The biggest challenges of radiation, bones, and enclosed environments is just one small part of living in space. Radiation, bones, closed habitats. If you're interested, our full free Living in Space, Radiation, Bones, Closed Habitats course is linked in the description.